Hello students, so today we are going to learn how to derive radius for the nth electron orbit using the Bohr model. So very first thing to remember here is that Bohr model is applicable only for hydrogen-like species. This is very important limitation of the Bohr model, that you can't apply it for multi-electron species. It is applicable only for hydrogen-like species, and hydrogen-like species means uni-electron or single electron species. Okay, so let's take an example where we have a species or an atom where the atomic number is Z. So atomic number Z means there are Z number of protons in the nucleus. So total nuclear charge will be plus Ze. Okay. And we have an electronic orbit around this nth orbit. So this is nth orbit. And let's assume that we have an electron here in this orbit having mass m, and radius of this orbit is r, and electron is revolving with speed v here. So this electron is performing circular motion here, or uniform circular motion. But you know that for performing uniform circular motion or any circular motion, any particle requires a force towards the center. This force is called centripetal force. So this electron will also require a force towards the center that we call centripetal force. And the centripetal force is not any new force. Any force present in the nature can act as a centripetal force. So this centripetal force will be provided here by the electrostatic attraction force acting between this nucleus and the electron, because electron will be negatively charged. So this will be attracted towards the center. So that attraction force will provide the required centripetal force. So electrostatic force of attraction between electron and the nucleus will provide the required centripetal force here. So the step for derivation of this nth orbit electron radius, that starts from this step only, that we will put electrostatic force of attraction that will provide the centripetal force. And how much will be the electrostatic force of attraction here? If you remember the Coulomb's law, that says the electrostatic force of attraction between two charges q1 and q2 separated by distance r is 1 upon 4 pi epsilon naught q1 q2 divided by r square. So what will be q1 here? The charge of the nucleus, so it will be plus Ze, and charge of the electron, that is minus e, but I am not putting minus sign here because I just want the magnitude of the force. So plus Ze into E divided by r square. So I have just written plus here, but you can ignore that. Plus Ze means Ze simply. And this is equal to centripetal required force, that will be mv square upon r. That is the expression for centripetal force for a particle of mass m moving on a circular path of radius r with speed v. So now we have here Ze square divided by 4 pi epsilon naught r square. This is equal to mv square upon r. Or you can write from here, this r square can be taken to the other side, and taking all other terms on the left hand side, you can write Ze square divided by 4 pi epsilon naught mv square, right? And this is equal to r square divided by r, that will be r. Now we are going to use, suppose this is your equation 1. Now using Bohr model. Bohr model has very important postulate. So using Bohr model says that electrons don't revolve in any random circular orbit, but they revolve only in those circular orbits in which their angular momentum is whole multiple of h upon 2 pi. What does that mean? That means mvr, the angular momentum of electron, that must be equal to whole multiple of h upon 2 pi. So that will be equal to nh upon 2 pi. So from here I can write v is equal to nh divided by 2 pi mr. Now I am going to put this expression for v in equation 1. Putting in equation 1, what will you have? Okay, if I put this in equation 1, I will have r is equal to, let's write other value, Ze square, and this whole thing divided by 4 pi epsilon naught m into v square, and we will put the value of v. So nh divided by 2 pi mr, this whole square. And if you simplify it, so this will be Ze square, this whole thing divided by 4 pi epsilon naught m into, if you square it, it will be n square h square divided by 4 pi square m square r square. So if you cancel this 4 with this 4, 1 pi will get cancelled with this 1 pi here, and this m will get cancelled with 1 m here. So this was value of r. So let's write it again here. So we have r is equal to ze square into, what will we have in the numerator? 1 pi, 1 m and r square, right? Pi m r square, and z square is already there, and whole thing divided by epsilon naught n square h square. So if you take this r square and 1 r is here, this r will get cancelled with 1 r, and now we can write r is equal to one single r, that is equal to epsilon naught h square n square, and this whole thing divided by pi m z square, or pi m square into z. So this whole thing here, this is constant, so we can write here r is proportional to n square divided by z. This is very important result, you should remember it. And if you put the value of other terms on this final result we have derived, then we will have small r is equal to epsilon naught value, you already know, 8.85 into 10 raised to the power minus 12 coulomb square per Newton per meter square, that is in SI units. So h is 6.6 into 10 raised to the power minus 34 joule second, we will put its square, and this thing divided by pi is 3.14 or 22/7, whatever you like you can put, into mass of electron is 9.1 into 10 raised to the power minus 31 kg, and 1.6 into 10 power minus 19 coulomb, that is the charge of electron, and it's square, and this whole thing multiplied by n square divided by z. And if you put all these values, what you will get? You will get this whole value in angstrom. If I write, this will be 0.529 angstrom. So 0.529 into n square divided by z. This is the radius expression in angstrom you have. Okay, and if you want the first orbit radius of hydrogen atom, so for H atom first orbit, what you will have for first orbit of hydrogen atom means G is equal to 1 or Z is equal to 1, and first orbit means N is equal to 1. So if you put N equal to 1, Z equal to 1 here, then we can put, this is the radius, this is called R naught, and this will be 0.529 angstrom, and this is called Bohr radius. This is called Bohr radius, 0.529 angstrom. This is the radius of the first orbit of hydrogen atom. Okay, I think you understood this, and one important thing I would like to elaborate little more here, that this final result I told you to remember here. So R was proportional to n square divided by z. So what can be the application of this? Many questions you can get in exams, that what will be the ratio of the first, second, third, fourth orbit for a single species, like R1 is to R2 is to R3 and so on. So you know that if z is constant, R is proportional to n square. So R1, R2, R3 ratio will be 1 square is to 2 square is to 3 square, means 1 is to 4 is to 9 is to, and so on. So this is one thing. And similarly, if you have hydrogen atom and helium plus ion, for them the radius will be inversely proportional to z. If you want to get the ratio of the first orbit for the hydrogen atom and helium, because it is inversely proportional to g or z, so you will write R radius of hydrogen is to radius of helium plus will be equal to 2 is to 1, because atomic number of helium is 2 and atomic number of hydrogen is 1. So I hope you enjoyed this derivation and the concepts I discussed in this video. If you like this video, please like it and subscribe my channel also, and share these videos with your friends also. So see you again next time with some other kind of interesting proof. Till then, take care, bye bye, and thank you.